Hello my dear students, welcome to our program for chemistry third secondary stage. Chemistry is very important for our life. Chemistry is a very nice thing to study.
Catch this word now, chemistry, that we need to start to work. I think you are ready now. What about to go? Let's go. Faraday. First law. I like this law. Are you ready for Faraday?
Yes.
Let's see and concentrate for the movie. Faraday. From the previous, we find that we can use the follow electricity in electrolytes. My dear, here we have much work. Look at this. Electrolytes
And neutralization of the ions. This solution in many industrial and laboratory application to put specific basis for this process.
flow in the solution and the quantity of material liberated at electrode in the two laws is called big name.
It's Faraday's laws.
Wonderful scientist Faraday, the physics twin, he depending on the two materials which are
Gas or solid formed to consumed at any electrode is directly proportional to the quantity of electricity that
passes in the electrolytic solution or molten. This reaction for Faraday or this work depending on solution or it's molten. So if you want to verify Faraday's first law, what you do for this?
by passing different quantities of electricity in the same solution and calculating the ratio masses of the formed materials.
The calculation for Faraday, first law, second law. Now, to make a relation between them, you be sure what is the difference between them. As a beginning, EMF equal electromotive force. This electromotive measured of the total electrical potential energy per unit charge available in the battery. This not all. Also, you can say the anode.
The anode and comparing this ratio by the ratios of of the passing of the quantity of electricity.
Which is the quantity materials between two. What and what?
Again we have gas or solid.
Demonstration, you have this meter which is connected by positive and negative to start to work. The materials are used, as we said it many times, solid or gas, but we depend on the second one. It means
the solid.
why we do that.
We have verified the Faraday's first law.
The connection on this road, as you see, and explain these steps. These steps to tell me what is the
mass of the first element.
Yeah, this not all. The source of EMF, it means the battery. Also, we depend on the
mass of the second element.
Good. Without them, we have no work. The masses between first and second element. This not all. Also, you must get the coil. This coil must calculate the
equivalent mass of the first element.
Only?
No.
What you do after that?
Equivalent mass of the second element.
So, to make a relationship between these two quantities, do it as you see. The law beginning with
the mass of the first element divided the mass of the second element equal what? Equal the equivalent mass of the first element divided on the equivalent mass of the second element. It is like the ratio between them. So the gram equivalent mass
of the substance is this. It means substance that has the ability to lose or gain 1 mole of electron. The motion of avometer, as you see, depending on Depending on what? Depending on the electron during the chemical reaction. So the gram of equivalent mass
equal the gram of atomic mass divide the number of charged ions on the element or of the element first.
Good to say that. So verify the second law of Faraday. But this laws depending on this circuit, for which consists of
Voltmeter and the connected wire to what? To the coil, and we have here a type of battery that we use it in chemical compounds.
Good to say that.
Here we have the substance that used to make what? To make electrolysis here by the Faraday's law. Electrolysis here, it means the electric circuit that happened or that formed here. The hydrogen liberated from this one, and we have the electric circuit. It means what? It means voltmeter, source of electric energy, and we have the chemical here or chemicals that found inside the container.
Ampere passing for the second one. Look at this. You have Faraday first and second law. What you do for these cases? As a beginning, you get these different beakers that contain copper sulfate and so on are connected by this ammeter. And I try to make the connection between the cells for serious measurement. Now, this connection by different cells to obtain high voltage. What about the intensity?
Intensity here, it means 1 ampere. It's passed in 30 seconds, for example, and we have the collection here of some kind of chemical compounds. After the current has passed for the certain time, hydrogen liberated in the cathode. Why here?
Here we say silver nitrate will be decomposed or ionized into Ag positive NO3 negative. Ag will travel directly to the negative 1. Oxygen will arrive to positive 1. What about the other side?
The other side, we have copper here that makes what? That makes losing of electron and it changing into what? Into positive 2 ions. And we have the electrolyte that's SO4 negative 2. After the current 1 ampere has passed for the second, here the hydrogen liberate in the cathodes and the oxygen liberate in anode. What are the reactions here?
The reaction here travel to the two different tube in the middle. One of them for the cathode and the other for the anode. Oxygen bubble evolved for the one. The other, it means hydroxide. Now the copper for both will be work and make different potential difference.
So the silver here in the other part, or number 1, we have Ag, aqueous solution that gain 1 electron that change into silver atoms. And the other one, we have copper. After the current 1 ampere has passed for a second, the copper deposited into the cathode and the copper ions liberated in an anode, dissolving anode.
Good to say that you have the copper positive 2 in aqueous solution plus 2 electron. Directly we have a copper solid. This copper solid will gain 2 electrons and it change into copper positive. The reaction is not stopped, it's work all time. Now you can arrive to important definition for this case. This definition, it means
that Faraday's second law, that definition is the masses of the different materials formed or consumed by the same amount of electricity that passes in different electrolytes connected in the series or are proportional to their equivalent mass.
Good. It's good to explain Faraday's law. Now look at this.
Faraday had deduced that the relation between the quantity of electricity which flow in the solution and the quantity of material liberated at electrodes, positive and negative electrodes.
Now you can say it can by simply verified by passing different quantities of the current in the same solution and also calculating
the ratio of masses of the formed neutrals or materials at the cathode.
Not all, but also you can dissolve it from the anode and comparing between them. Why? This ratio by the ratio of the past quantities of electricity. Get a look.
Here we have the quantity of electricity. It is the rule equal the current strength by ampere or the current intensity by ampere times what? Times the time that measured by seconds.
Faraday first law. This is the definition. State that the quantity of the formed or consumed material at any electrode of it is
Gas or solid is directly proportional to the quantity of electricity that passes in the electrolytic solution.
This is the definition for Faraday first law. Second law, the masses of different material formed or consumed by
the same amount of electricity are
directly proportional to the quantity or equivalent
masses.
It's good. This is the second law. What about to make a relationship between first law and the second law of Faraday? This depends on that.
So, for example, we have the masses of the formed materials that are hydrogen, silver, and the copper that we said, or we saw this one in what? In the video. Silver and copper are potential or proportional to their equivalent mass as the following.
Look for this. Hydrogen, silver, and copper. 1 to 107.88. Copper 31.78. Related to second law of
Faraday.
It's a good physics. Now look for general law.
General law of electrolysis. It means what? When 1 Faraday it's equal 96,500 coulombs. It means the quantity of electricity measured by coulomb. So it passed through the electrolyte. This will lead to
dissolution of grams of equivalent masses from the substance at any electrode. But my question, all time 1 Faraday equal what?
Equal 96,500 coulombs of the quantity of charges.
Good. Don't forget this number because we will use it for many problems. Now look for the main law.
General law of electrolysis. It mass of deposited substance by gram. It makes or equal what? Equal time per second times the equivalent mass of the element times the current by ampere or current intensity divided what?
Divided 1 Faraday or 96,500. It's a good law. This law is important and we have sure problem for exam. You must study it well. Final exam needs this law. Now let's see the example.
So the example here. Concentrate with us very well to make this example. What are the masses of gold and chlorine produced from passing 10,000 coulombs of resulted electricity in aqueous gold chloride solution? It's very important to know the gold and the chlorine in the same solution of each one of them as the following reaction. What is the reaction here?
Au positive 3 plus 3 electrons negative give me Au. It means gain these electrons. But the other one it means
2Cl negative ions that lose 2 electrons and change it into Cl2 as molecules of chlorine. So this is the reaction here that happened between the ions of chlorine and ions of gold. What's the given else?
The given directly, he say you must write number 1 equivalent of the gold equal 196.98 divided 3 per 3. What is meant by this 3 especially?
It means the valency of what? Of the gold. It is positive 3. you have this number on the ion of what? Of the element or the metal that you have in this problem.
You must know if you don't keep these numbers, you can find it from the symbol, which we said before, AU positive 3 was studied for the equation. Directly the answer 65.6631. You can say this is in gram, especially for the gold. This all?
No.
What you have now?
We have another one equivalent mass of chlorine, the same methods. We have 35.45 divide 1. What's meant by 1 here?
1 here, it means the valence of the chlorine. It means what?
What's the meaning of 35.45?
Oh, I think this is the mass number for chlorine. It's good. Division have an answer.
35.45 grams of what? Of chlorine as an equivalent mass.
Good. Stop until here. Now you have the equivalent mass for the both chlorine and the gold. Now, what you have after that? This is all answer?
No.
Find the answer now.
We have the answer. We must write the rule of each one of these parts to get the equivalent masses. Here we have the mass of deposited gold equal what? Equal
10,000 by 65.66 divided 96,500. It's 1 what?
1 for a day.
I know it, 1 for a day. So the answer 6.8
grams.
Good to say that. The unit is very important. But also we have
the mass of deposited chlorine. Here 35.45 times 10,000 coulombs. Divide what? Divide 1. What's meant by this? We have here 35.45 grams.
the other example. Tell me what is the quantity of the electricity necessary for separation of 5.6 gram of the iron 3 chloride, where the cathode reaction will be as the following. Say it and look.
Iron positive 3 plus 3 electron that gain 3 electron to change it into atom of iron. And we have the iron or mass number of the iron. It's equal what? Equal 55.68.
Good. But what is the valence of the iron for this case?
Here the valence is positive 3.
How do you know?
Know that from the number of positive charge that found on the Fe symbol. So the 3 or the 3 electrons that found beside it.
That's what we needed to answer and find the mass. Now, you have the answer for these steps. The equivalent mass of the iron equal atomic mass divided valency equal
55.68 divided 3. It's equal
18.62 grams. What else after that?
Here we have the mass of deposited iron. It's 6.5 times 96,500 divide 18.62. What is this number?
This number, it means you have Faraday also. So the cross multiplication between this law, depending on the law, find the final result as you see 290,022.5 coulombs. Why we say coulombs for this case?
Because we need the amount of electricity that produced or that needed to make what? To make this deposited of iron.
It's good to say that. So the unit is changed according to the changing for the wanted for this problem. You must be sure you have a full mark for the answer, God willing. What the other one? The first one, as you see, application electrolysis. I like it. The first?
First here we have the does the dissolved ionic compound conduct electricity? What's meant by this? We have here the sodium chloride. I need to know that this one or this solution to make what? To conduct electric energy or not. So number one, we have play to find out what's happened when the current passed through the sodium chloride here. First thing, we have the stage number 1.
Sodium chloride in ACl is an ionic compound made up of the sodium ion Ne positive and the chloride ion Cl negative. When the current is switched on, what will happen to the bulb?
Here we have this switched on like this as stage number 2. When the current passes inside this solid, sodium chloride doesn't conduct electricity because its ion cannot move or cannot make any motion because it is solid state. What happened if you dissolve it in water?
You have the aqueous solution. The solid sodium chloride is added to some distillated water and dissolved to form the colorless solution. When the current is switched on it, what will happen to the bulb?
The bulb will be light up like this. Why? Because here the electric energy that pass inside this solution and show that the solution of sodium chloride doesn't conduct electricity. Why that this happened? Because what?
Because directly you have the ions move through this aqueous solution. Now you must know the ions of sodium chloride are free to move when they are
dissolved in water and so conduct electricity. The electricity also causes reaction
to take place at electrodes. It's good to say that this explains the motion of the ion through this circuit. But also we have
the stage number 6, a green gas that formed at the positive electrode, that's called chlorine gas. So the positive electrode and the colorless gas in the negative electrode. What has been produced from the sodium chloride and water here? We have a summary about this.
Sodium chloride that is dissolved in the water conduct electricity and the current causes both of the this substance to break down. This produce chlorine, hydrogen and
sodium hydroxide. Here we have electrolysis of a molten lead bromide. The molten ionic compound can be split into Into element by passing the electric current through it. Why? Because here we have electrolysis. Click play to find out what's happened during this reaction.
This reaction has many stages. The first stage, when the molten lead bromide conduct electricity, it is split directly into its elements. The first element is bromine gas, form at what? At the positive electrode, and the lead forms at the negative electrode. But my question, how does this happen?
So this one, it's about what? It's the second stage that happened here. The ions of lead here, bromide, PP positive 2 and Br negative, they are free to move. It's very important to know this. Free to move, so when it's molten state or solution, so they are attracted to the electrodes. Why? Because they are moved inside the solution or molten one, where the redox reaction that's happened or occur. This question here, we have what's happened at each electrode.
This electrode, for the first third stage, we say the positive lead ions, Pb positive 2, are attracted directly to negative electrode. They gain electrons. We know that. Form what? From the current and form lead atoms, Pp. The Pp positive 2 ions have been reduced. It means electrons here were it's lost. Now, what you have after that?
We have here stage number 4, the negative bromide. It will have what? This is Br negative 1. Ions move to the positive electrode as we see here in this figure. So the positive electrode, it attracts the Br negative 1. Why? Because they have different charges here. They lose electrons and becomes bromine atoms. Why? To make what? To make the molecule of bromine here, Br2. To make what? To make this is in the gaseous state. The Br ions have been oxidized. So here we have in this stage, in the negative or the negative or positive electrode, we have oxidation. And here we have the other one, we have reduction. What about the stage number 5?
The redox process at the electrode split molten lead bromide into what? Into its element. Bromine forms at the positive electrode and the lead forms at the negative electrode. Now, lead bromide give me lead plus bromine, Br2. What you say?
Here we have Br2, liquid state, change into what? Into Pb, liquid, and we have here Br2 in gaseous state. So the bromine forms at the positive electrode and the lead forms at the negative electrode.
It's a good electrolysis and easy to learn that. Good and wonderful.
We have, does each of the substances connect or conduct electricity or not? To know what? To know which one of them is electrolyte or which one it is not electrolyte.
The first one we say solid copper sulfate. Conduct electricity or no? Yes?
Here we have solid copper sulfate doesn't conduct electricity.
Molten lead bromide. Do you think conduct electricity or no? Sure, we know it's a good conductor of electricity because it's what?
It's molten lead bromide because it is molten, so we have what? We have this is the ions that move inside the solution or molten one. So we have another one.
Another one, sodium chloride crystals. It means conduct electricity or no? Directly we can say it's what? It's solid. Good or bad?
It doesn't conduct electricity because it is solid crystals.
Good. But you need a molten. What is the other one? The other one is
solid lead bromide. So the solid lead bromide, it's solid one, doesn't conduct electric energy because what? It contains crystals. It contains non-movable ion. So the ions here doesn't move, so it makes what? It makes doesn't conduct electric energy.
the other one, sodium chloride solution. Yeah, we know. Solution, it means motion of the ion. It means a good conductor of electricity. The answer directly for all.
We have what we have, the copper sulfate and molten lead bromide, and we have sodium chloride solution and molten aluminum oxide. They are conduct electric energy as they have motion or movement ions.
The other one has no ions. It means doesn't conduct electricity. Solid copper sulfate, solid lead bromide, sodium chloride crystals.
Dear friends, I hope to enjoy your time with us. It's a very interesting part about our curriculum today. Till we meet again, thank you and goodbye everybody.
Good. And I want to say start well because we need to work all time. The work is very important. No chemistry without working. See you and goodbye.
أعزائي طلبة وطالبات الثانوية العامة، أهلا ومرحبا بكم في حلقة جديدة من حلقاتنا لمادة الهندسة الفراغية. اتعرفنا في الحلقة اللي فاتت على المستقيم العمودي على مستوى. النهاردة بنتعرف على المساقط، نستخدم فيها أيضا التعامد، مسقط نقطة على مستوى ومسقط قطعة مستقيمة على مستوى. بنتعرف أيضا على تعريف هام جدا وهو زاوية ميل مستقيم أو قطعة مستقيمة على مستوى. أيضا بنتعرف فيها على نظرية 4 وعكسها، ونطبق الكلام ده في الأمثلة والتمارين. تعالوا